So today we're going to be talking about position versus time graphs. And so when scientists want to model the motion of an object, they will create a position versus time plot or a position versus time graph. And so remember, whenever we're titling our graphs, we always put the title overhead here, position versus time. Scientists will put the position data on the y-axis. So we'll see right here, they'll write position. Remember that position is measured in meters, so we're going to include the units over here, meters. And the time data will then be on the x-axis. So I'll write time down here, and that'll be measured, in seconds. If the object has a constant velocity, so if the object is moving at the same speed, the data will make a straight line. So in other words, if the speed isn't changing, the data will be in a straight line. So here we can see this object will be moving at a constant velocity because the data points all make a straight line. Right? We can put a straight line through the data points. The slope of the best fit line is the velocity of the object. So remember, slope, that's rise over run. So when you take the rise of the line over the run of the line, that tells you how fast the object is going. It tells you the velocity. The y-intercept is the starting position of the object. So right here we can see this point is the y-intercept. It tells you where this object begins when we started tracking its motion. Okay, so there's 4 steps for calculating slope. The first one is to draw the rise and the run on the graph. Second one is to find the rise, which is in the case of position versus time graphs, the rise is the change in position. Then you're going to find the run. How much does the time change? And lastly, you'll divide the rise by the run. Okay, so let's go through those 4 steps for this graph on the left here, because we're going to find the slope. We're going to find the velocity of this object using the slope of the graph on the left. So first up, we're going to draw the rise and the run on the graph. Whoops. Let me go back real quick here. The reason why dividing the rise by the run works to find the slope is because if we look at our velocity triangle, velocity is position divided by time. Well, the rise is your change in position. The run is your change in time. So the velocity is just the position divided by the time. So that's why the slope is just going to be the same thing as dividing position by time. Okay, so you're going to find the velocity using the slope of the graph on the left. So step 1 is draw the rise and the run on the graph. So here's the rise. Got that drawn in right here. Here's the run. I've got that drawn in right here. Step 2 is going to be find the rise or the change in position. So we're going from 8 to 14. 14 minus 8 is 6. So we've moved up 6. Next, we're going to find the run, the change in time. Well, we're going from 1 to 4. 4 minus 1 is 3. Okay? And so then we're going to add units. Excuse me. 6 meters. Right? Because when we're going up and down on the y-axis, we can see that our position is measured in meters, so 6 meters. 3, as we go left and right on our x-axis, that's our time, 3 seconds. Okay? So then our last step is going to be divide the rise by the run. So we're going to divide 6 meters divided by 3 seconds. And we're going to end up with 2 meters per second. And so then the velocity is 2 meters per second. Last up, we're going to find the starting position using the y-intercept of the graph on the left. Here's the starting position right here. It's at 6. And so we'll say the starting point is at 6 meters, or the starting position is at 6 meters. We'll go through a few more examples coming up in a bit here. All right. So if the slope is positive, the object is moving forwards. So here we've got an object with a positive slope. This object would be moving forwards. If the slope is negative, the object is moving backwards. So here we've got a position versus time graph where the slope is negative. We can tell because as we go to the right, it's going downwards, right? Whereas in this one, as we go to the right, it's going upwards. So this one, since we're going to the right and it's going downwards, that means it's negative. So that means this object is moving backwards. If the slope is 0, then the object is not moving. So here we've got an example of a position versus time graph where the slope is 0. It's just a flat line. That object is not moving. So faster moving objects are going to have steep slopes. So here's an example of a steeply sloped line. So this object would be moving more quickly. Compare that to this graph right here. Right, slower moving objects will have gradual slopes. So in this graph, we can see the line's still moving up, so it's still moving forward, but the line is much less steep, and for that reason, the object in this position versus time graph is moving a lot more slowly. Lastly, non-moving objects will have flat slopes. So excuse me. Well, we kind of showed this on the last slide, but objects that aren't moving are just going to have these flat slopes where the slope is 0. Okay, find the velocity of the object using slope. So let's just go through an example of this. So remember, step 1 for the slope is we're just going to put the rise and run on the graph. The rise in this case looks like it's going up 1, 2, 3. The run looks like it's going over, well, 12 minus 3 is 9. Okay, and so then the rise, it's going up 3 meters, and the run, it's going over 9 seconds. So 3 meters, 9 seconds. So next we'll find the velocity by dividing. So we're going to take 3 meters and divide it by 9 seconds. And that's going to equal 0.33 meters per second. So the velocity of the object is 0.33 meters per second. Find the starting position using the y-intercept. This is the y-intercept right here. And so we can see the starting position of the object is 4 meters. Find the velocity of the object using slope. So we're going to draw on the rise and the run. Now notice this one is slanting downwards, so that like as we go to the right, the graph is going down. What does that tell us? Well, it tells us that the slope is going to be negative. So since I'm counting down here from 12 to 6, this is going to be negative 6. And the time should always be positive. Time is 3, 1, 2, 3. So this is negative 6 meters. This is 3 seconds. Negative 6 meters divided by 3 seconds is negative 2 meters per second. So the velocity of the object is negative 2 meters per second. And then find the starting position using the y-intercept. That's the y-intercept right there. It looks like it's at 14. The starting position is 14 meters. Okay, last one. Oh, well, this one, the velocity is going to be 0 meters per second because the line is flat. So the velocity of the object is 0 meters per second. And then find the starting position using the y-intercept. It's right here. The starting position is 5 meters. Hopefully that makes sense. If you have any questions, as always, please contact me so I can help you out.